Hello everyone! In this lesson, we'll learn about two important instructions used on the Siemens PLC side when FANUC industrial robot communicate with Siemens PLC via the in-the-night TCP/IP protocol. Siemens S7 1200 PLC supports multiple in-the-night communication protocols such as OPC, TCP/IP, S7, and Modbus TCP, etc. Among them, the TCP/IP protocol communication method is also known as Open User Communication, which is socket communication method. Next, please answer this question. Which protocol does the Siemens S7 1200 PLC support for in-the-night communication? A. OPC UA. B. Modbus RTU. C. TCP/IP. D. Profinet. I will give you 5 seconds to think, and will show the answer after 5 seconds. The answer to this question is C. Did everyone choose the right answer? First, let's learn about the pin functions of the TSEND and the TRCV function blocks. In this lesson, we'll focus on the TSEND and TRCV function instruction blocks used when Siemens PLC sends and receives data via the TCP/IP protocol. The figure below shows the TSEND function block. Its input interface parameters and corresponding explanations are shown in the figure below. Its output interface parameters and corresponding explanations are shown in the figure below. Next, let's focus on several key parameters. REQ, rising edge, triggers the send operation and related to establishing the communication. CONT, when set to 0, disconnects the communication. When set to 1, establishing and maintains the communication connection. LEN, the maximum byte length to send. If set to 0, all data specified by data will be sent. Data, a pointer to the send area, which contains the address and the length of the data to be sent. Specifically, as shown in the figure, a pointer is written as p#db1.dbx 0.0 byte 3, which means the pointer points to 3 bytes starting at address 0.0 of data block 1. Thus, the send area includes the data of 3 bytes starting from address 0.0 of the DB1 data block. Next, please answer this question. In the TSEND function block of a Siemens PLC, which parameter specifies the maximum byte length of the data to send? A. REQ. B. CONT. C. LEN. D. Data. I will give you 5 seconds to think, and will show the answer after 5 seconds. The answer to this question is C. Did everyone choose the right answer? Okay, let's keep going. Of course, we can also assign the entire SEND data area in DB1 to data, as shown in the figure. DONE, done, status parameter. When it's 0, operation is not started or still executing. When it's 1, operation is completed without errors. Busy, status parameter. When it's 0, operation is not started or completed. When it's 1, operation is executing and can't start new operation. The figure below shows the TRCV C function block. Its input interface parameters and the corresponding explanations are shown in the figure below. Its output interface parameters and the corresponding explanations are shown in the figure below. Next, let's focus on several key parameters. ENR enables the receive function, which can be defaulted to 1. CONT, when set to 0, disconnects the communication. When set to 1, establish and maintains the connection. LEN, maximum byte length to receive. If set to 0, it will receive the data length specified by data. Data, a pointer to the receive area, when contains the address and the length of the data to be received. Specifically, as shown in the figure, a pointer is written as p# db1.dbx 12.0 byte 3, which means the pointer points to 3 bytes starting at address 12.0 of data block 1. Thus, the receive area includes 3 bytes starting from address 12.0 of the DB1 data block. Next, please answer this question regarding the data parameter in the TSEND C function block. Which of the following descriptions is correct? A is a status parameter indicating whether the job is completed. B is a pointer to the starting address and the length of the send data. C is used to send the PLC's IP address. D, it determines whether the communication connection is established. I will give you 5 seconds to think, and will show the answer after 5 seconds. The answer to this question is B. Did everyone choose the right answer? Okay, let's keep going. Of course, we can also assign the entire received data area in DB1 to data, as shown in the figure. Next, let's learn about the configuration process for TSEND C and TRCV-C. We'll use the Siemens PLC as a server communicating with a third-party PC via TCP IP to illustrate the application process of these 2 instructions. Create a new project and set the IP address as shown in the figure. The PLC IP address must be in the same subnet as the PC. Click Protection and Security, then Connection mechanisms. Then check allow PTU-GET communication access from remote objects. For PLC, you need to check the allow PTU-GTE communication access from remote objects. Next, create a global data block to store data for sending and receiving. Both the send and receive areas are arrays of 6 bytes. To allow direct access to DB block data by the third-party PC, disable optimized block access. Continue. Add the TSEND and TRCV instructions. Here, the TSEND and TRCV instructions are used in combination to complete the communication. Add the TSEND and TRCV instructions from the communication sections on the right to handle data transmission and reception during TCP communication. Configure the TSEND and TRCV blocks as shown in the figure. Partner settings. Select unspecified since the PC is used as a host computer. Set the IP address to match the host computer's IP. Set the partner port to 3000. Local setting. For connection data, create a new entry. A system data block PLC1 send data will be generated by default, and the connect pin of the TSEND block will automatically reference this data block. Since the PLC acts as a server, check actively establish connection on the partner side. The client is responsible for initiating the connection. Accept the default values for connection type, configuration mode, and the connection ID when creating the connection data. The connection ID must match the ID pin of the TRCV block. The figure below shows the configuration parameters for the TRCV function block. Next, please answer this question. During the configuration of the TRCV function block, which parameter must match the corresponding parameter in TSEND function block? A. IP address. B. Port number. C. Connection ID. D. Data block address. I will give you 5 seconds to think, and will show the answer. After 5 seconds, the answer to this question is C. Did everyone choose the right answer? Okay, let's keep going. After completing the above steps, we test the communication between the Siemens PLC and the PC. If the status of the TSEND block shows 16#7004, the communication connection is successful. The PC client should display the data sent from the PLC, as shown in the figure. If the status of the TRCV block shows 16#7006, the communication connection is successful. When the PC client sends 7 bytes to the PLC, the data is received and stored in the receive array specified by the data pin of the TRCV block. Everyone, in this lesson, we've learned about the TSEND and TRCV instruction of Siemens PLC and demonstrate the TCP/IP communication process through examples. We should master the parameter configuration and setup methods of this instruction, and lays a solid foundation for the TCP/IP communication between Fanuc Industrial Robots and Siemens PLC. For more practical examples, please watch the related operation videos in this course chapter. That's all for this lesson. See you next time.